This video will begin with the Robotics with the Bobot Student Guide version 3.0. You should have already completed the basic help menu or using a Chromebook document. In the table of contents, it shows you in Chapter 1 your Bobot's brain, getting the software using the help file for hardware setup, and so forth that you should have already completed. However, we can go ahead and start with chapter 1 because there are some interesting bits of information in there that we should make sure we're good to go. Here's what your Bobot will look like after it's built. The Board of Education will be sitting on top, and if you can see here, the Bobot will have the battery pack located underneath. If you are using a 9-volt battery, the battery will just simply stick out. These are directions for how to use the Windows version of the software, and there are some questions and exercises you can go through. We already did the debug DEC 7 times 11 earlier, and these are just some questions you can answer if you want to test yourself. And here's some projects you can do if you want to do a different math problem. In the student guide, it also provides what should happen or what the answers are to the exercises. Okay, let's go ahead and start with chapter 2, your Bobot's servo motors. Your servo motors look like this. Each of the servo motors contain a control horn, a Phillips screwdriver, a label, and this is a continuous rotation servo motor. There are different types of servo motors. This one is a continuous rotation. Where you see the cables insert, there is an access hole for center adjusting the feedback potentiometer. A potentiometer is using two different words here. Potentio or potential is another word for voltage. Meter is for measuring. Now, you may be excited to get started with your servos. However, before you do the servos, there are activities you need to complete first. So please do not go and skip down to the servos. You need to do this in the correct order. First, we need to build and test an LED circuit. Remember, a circuit is where you have a closed loop of electricity, and in this case, where you've completed your breadboard. Let's go ahead and start with our pause command, which we learned previously. You should hopefully already have up your Parallax IDE software. As you can see, I still have the previous ASCII name.bs2 open. What you can do is just click a new file, and we're going to go ahead and put in our pause command. So remember, pause 1000, this means, putting a comment here, 1000 milliseconds is equal to 1 second. As a reminder, debug, we can put in any message we want. And remember, end is used to indicate that we want to stop the program from running. When you click Save File, you can save it as anything you want. Make sure you try to use all one word with no spaces and put BS2 on the end. Make sure to turn on your Board of Education and then click on Download. Once you run the program, you should see everything working down below. Okay, at this point, let's go ahead and start with the example program timedmessages.bs2. Now, for the moment, we're going to be given the entire program, so we can go ahead and copy, make a new file, highlight everything, or do Control A on your keyboard, and then Control V or paste. Let's go ahead and save this file as timedmessages.bs2. Timemessages.bs2 is to start using the pause command, and we can then indicate messages or any sort of program after the pause. And you can do multiple lines of pausing or debug commands or any sort of commands you want. Let's go ahead and give it a try. My Board of Education is still on number 1, so I'm going to click on Download. And it started the timer. 1 second has elapsed. 3 seconds have elapsed. And immediately it records done. Again, if you want to try this again, just go ahead and click on the reset button. Also notice that we used that CR as we learned in the previous video. CR allows for the next line to be shown like this. It's best to use CR when you're doing any sort of messages. Okay. Now, here's where things are going to start getting a little tricky. The book is no longer going to indicate exactly what to type. It's going to tell you enter, save, and run the program, such as timed messages. Now, I want you to give it a different program, but similar, so you can try it again. Now, also, the longest possible duration argument is 6,000 or 65,535. So if you want to try for that long, you are welcome to do that. But let's just go ahead and change it to 5 and 15 seconds have elapsed. So in our program, we're going to pause for 5 seconds, which is 5,000 milliseconds. And then immediately we're going to have the debug command indicate 5 seconds have elapsed. Now remember, if we want 15 seconds to have elapsed in our next message, we want 15 minus 5, which is 10. So that's going to give us 10,000 milliseconds. Let's save it, download it, and see what happens. Okay, program worked great. Now, here's another program we can do, and this is a very common program. It's called do and loop. A do and loop is where you can have the program complete a specific amount of tasks and then at the end have it loop back to the top of the do line. So let's go ahead and have it do a debug command and then do a new line, CR, and then pause for 1 second and then have it do it again. This is going to make the hello once every second occur. Again, notice the directions. Enter, save, and run hello once every second.bs2. Now it does give it to you here, but let's go ahead and try it on our own. So let's make a new file. We do not need to include the comments at the top, but you can do it if you really want to. Let's go ahead and type do. Now notice what happens if I make everything lowercase. It's still blue or capital and lowercase. However, the appropriate syntax is all capitals. Push enter on your keyboard. Now we're going to go ahead and cause the debug to say the words hello, exclamation point, and the quotation marks will no longer be shown in the debug command, and then comma CR. We're going to do enter and do pause for 1 second, which is 1000 milliseconds. Enter again and then loop. Okay, let's go ahead and save this file. The book wants us to name it hello once every second. .bs2. Okay, let's go ahead and try and click on download. This program will continue running until we turn off the board. Okay, let's go ahead and turn off the board and the debug terminal will stop producing the hellos. Now, what you can do to slightly modify the program is to start with a message and then have the do and loop after a message. So let's go ahead and add this by making a new line between those top two items. And then debug hello. And then in this area we were in earlier, it just wants us to put an exclamation point and then cause the loop to occur again. Now, if you turn the board back on, it's probably going to start with the hellos again, but let's go ahead and click on download. Notice what happens. Okay. Now, notice what happens when I left the CR. It made a new line. It doesn't seem like that's what we wanted to do. What we really wanted was for the hello to continue having the exclamation points after. So let's go ahead and remove the CR, save it, and download it again. All right. Seems like that's what the book wanted us to do. So notice that you can include the CR command or the do and loop command in any order you want, as long as it makes sense for what you want the board to do. Let's try activity number 2, tracking time and repeating actions with a circuit. Now we're going to start emitting some light to see the signals happening eventually to the servo motors. For the moment, we're just going to build some lights using the LEDs. This is going to start introducing what an LED and a resistor is. In your kit, you should have various resistors that look like figure 2-2. Now, that figure makes it look a whole lot bigger than it really is. This is what it looks like. Now, if we zoom in, let's see if we can get this to work. All right, little challenging with the focus, but you can notice that there are these colored bands on it. The colored bands indicate the ohms indicated by the Greek letter omega, which indicates the amount of resistance. Now, if you use a water example, resistance is something like squeezing to make the pressure go higher, where voltage would be your pressure. So, the more resistance you put in, the higher the voltage. Not necessarily the amount of electricity going through, which is the amps, but it is just the amount of resistance occurring. The bands tell us which ohms we are using. In this case, the yellow, violet, brown, these are the colors that indicate the 470 ohm resistor. The gold, silver, or blank area at the end um, is not necessarily used to indicate which type of resistor you have, but it is used for some other purposes. Don't worry about it. The other thing is you need to make sure you have it facing the correct direction. Okay, next is your LED. Now, an LED stands for a light emitting diode. Without getting too much into it, a light emitting diode is a light bulb. Now, what this diode does is it specifically makes light come out of the top by having electricity go through a certain path. Notice this symbol here. This symbol on the bottom is your LED. It has an arrow with a vertical line and two lines going down. Now, on the LED, there are two different lengths of the LED wires. However, it's not that easy to be able to tell what the lengths are, especially if your wires are bent. But you can see some minor differences. Notice that this one is just a little bit shorter than this one. Also, according to the picture, you can see that there's actually a flat area on the LED red light, and that also indicates the negative side. Now, you should also learn some new terms. The positive side is called an anode. The negative side is called a cathode. Each of these terms refer to the direction in which the electrons in the electricity are flowing. You need to remember that the positive sign is an anode and a negative sign is a cathode. Okay, let's go ahead and move down to the LED test circuit. Now, before you put any LEDs or resistors into the breadboard, you need to make sure that your Board of Education is off. You'll know that by your LED light being not on. There is a "What's a microcontroller" text, and you can get familiar with circuits using that if you want. But let's go ahead and get started. We're going to go ahead and build this circuit using this breadboard. First off, you will need to put in your resistor. Now, notice the diagram on the left. It's indicating that we're going to start with P13, and the resistor is going to be input into P13. On the board, on the picture on the right, you'll notice that P13 is located to the left of the board. Again, make sure that your colors are facing the correct direction. Okay, so the yellow, violet, and brown, the yellow should be facing to the right. All you have to do is find P13, 15, 14, 13, and then you just simply push the wire in. You don't have to do a whole lot of force. It's a very small distance. Now you're going to take a look at the diagram, and the diagram shows that the other end of the resistor goes into where the LED is going to be. Now, taking a look at the breadboard, specifically, we want the same row that the breadboard will contain the LED light. Specifically, the positive. Remember, that's the anode. In this example, we're going to go ahead and put the other end in the top row of the VSS part of the breadboard. And it just slides in. Don't be afraid to move and bend the wires until it's in the correct place. Next, we're going to take our positive anode. Now, if you don't remember what that means, go back to the picture. The positive is the longer one and has the little tab facing out. Okay, so we want the positive longer one to be in the same row as the P13 resistor, and we want the negative cathode to be in the VSS for power for the, or excuse me, for ground for the LED. So pop that in there like that, and put the, oops, make sure your wires are lining up. All right, there we go. Okay, we're also going to do another one. because we're going to be using two different LEDs to indicate um, the two different servos we're going to control. So we're going to go ahead and do P12 and basically do the same thing, just one uh, row down for both the P's on the left and the VSS slot on the right side of the board. Okay, so again, make sure your yellow is facing to the right. One spot down. Oops. Okay. One spot down. There we go. And then, again, the longer anode side goes directly in the board. And again, make sure it's in the same row as the new resistor we just put in. And then into one of the ground spots up above. Okay, and we should be good to go. Now you can't necessarily test this yet. What you're going to have to do is program the board to cause it to turn on the power specifically to P13 or P12. Okay, so remember, electricity is about electron flow. What we've essentially done is taken the VSS, which is up above on the top. The electrons are going to flow and then come down and then over to the VDD, which are our P13 and 12. Now remember, this is a closed circuit now. If you use the other version of 2.5, where you just plug everything into VSS or everything into the breadboard, you're not closing the circuit. What you're doing is you're just making both ends directly into one side of essentially a battery. Okay, let's go ahead and give this a try. The high and low commands can be used to make the basic stamp connect an LED alternately to VDD and VSS. The pin argument is a number between 0 and 15 that tells the basic stamp which in-out I/O pin to connect to VDD or VSS. High pin or low pin. Pin you replace with a number. For example, if you use the command high 13, it tells the basic stamp to connect in-out pin P13 to VDD, which turns the LED on. Likewise, if you use the command low 13, it tells the basic stamp to connect I/O pin P13 to VSS, which turns the LED off. Let's go ahead and try this. Let's turn on our board. Make sure your light is on. Enter, save, and run high-low LED BS2. You can go ahead and highlight this. Make sure you don't highlight the little period at the end. Or you could highlight just this one. Might be a little easier. And notice the program is probably running on your debug terminal again. Let's go ahead and do new file, save file, and give it the name. Okay, we can go ahead and copy and paste this if you want, or you can do it yourself. Let's go ahead and do it ourselves so we get used to doing this. Debug, let's go ahead and do a command here. The LED connected to pin 13 is blinking. Okay. debug, the LED connected to pin 13 is blinking. Now we want to do a do and loop command. Let's go ahead and do do. We want high 13, indicate to turn the power on to 13. We want to pause, and it says we want to pause for 500 milliseconds, which is half a second. Then we're going to turn it off at pin 13, meaning low 13, and then pause for 500 and then loop again. Okay, let's go ahead and save our file, click on download, and run it. Again, I switched it to number 2. Notice that it is blinking. Awesome. Okay, I'm going to put it back to number 1. Now the book wants us to go ahead and try this again. But this time we're going to do it with the other LED. Before we do, you need to understand this diagram that's going to show up quite often in the book. This diagram shows the VSS VDD occurring where you have 0 volts for VSS and 5 volts for VDD. The time for the high command is 500 milliseconds, and for the low command is 500 milliseconds as well. Notice that this is just a graph going up to the voltage and down to the 0 voltage. The total time is 1000 milliseconds or 1 second. So every time this blinks on and off on the LED, 1 second has occurred. Okay, let's go ahead and try it with the other one. All you have to do is change which pin you are using. So let's change it to 12 instead of 13. Save and download. Again, make sure that you're on the number 1 switch. And now the other one is blinking. Let's go ahead and play with this a little. Let's make both of them blink. We can make both of them blink at the same time. Let's go ahead and add in high 13 and low 13 as well. Save and download. And there you go. You'll see that both of them are now blinking. What if we wanted one of them to blink first and then the other one to blink? Well, what we could do is instead of having the high 12 and high 13 together, let's go ahead and put after the pause for low 12, let's go and put high 13, pause 500, then low 13, and then pause for 500 again. This should make each one blink alternatively. Save file, download, and let's see what happens. And there you go. So you're free to go ahead and play with this as much as you want, but this is your introduction into activity 1 and 2.